Hello everyone, my name is Nandini. Today we are learn about transfer learning technique in deep learning. Transfer learning is a powerful concept in a deep learning where a model developed for one task is reused as the starting point for a model on a second task. It's especially useful when you have limited data for the second task. Now let us we can learn about transfer learning. Transfer learning is a research problem in a machine learning that focuses on storing knowledge gained while solving one problem and applying it to different but related problems. That means transfer learning is a concept in a machine learning where knowledge is gained from one problem is stored and applied to different but related problems. Here is the one of the example of transfer learning is cat and tiger. Learning to recognize cats can help when trying to recognize tigers since they share a similar features. Now here we can see the building complex models in functional API. The Keras functional API is a way to create a models that is a more flexible than the tf.keras.sequential API. The functional API is a way to build a model in Keras that offers more flexibility than the tf.keras.sequential API. It supports non-linear model architecture, shared layers, multiple inputs and outputs. The benefits of it is enables the construction of models with complex architectures, such as the wide and deep model shown in the diagram. Allows the network to learn here is deep patterns through the deep path and simple rules through the short wide path. This diagram shows that if we give the input layer and it go to the hidden layer first and then it go to the hidden layer second, and this input layer what we give that concat and it shows to the output layer. Now also we can here learn about building complex models functional API. The model with here is the main points is model with multiple outputs. A Keras model is defined with two outputs. First is a main slash output and second one is a AUX slash output. The outputs are created using a Keras dot layers dot dense layers. The model is defined as Keras dot model inputs is equal to input slash A, comma input slash B. The output will be output AXU slash output. Compiling the model, since there are multiple outputs, each output needs its own loss function. The model is compiled using a list of losses and optional weights for each losses. Key concept of functional API is functional API allow more complex architecture than a sequential. You can define a models with a multiple inputs and outputs. When compiling such a models, you must provide a list of losses, one for each output. Optionally, a list of losses weights to priorities one output over the other. Now here can also see the reusing pretend layer. The main summary of this reusing pretend layer is the avoid training large DNN from scratch. Inside the reuse the lower layer of a pretend network that was trained on a similar task. This method is known as transfer learning. The benefits of a transfer learning is faster training and require less training data. The output layer of the original model is useful, usually not useful for the new task. It should be replaced as it may not match the number or types of outputs needed for the new task. The key concept of the reusing pretended data in transfer learning is transfer learning is an efficient way to leverage existing models, especially when you have limited data or con- con- compute resource for a new but related task. Here is one of the transfer learning workflows. Reuse in this diagram we can explain the reusing pretend layer. Reuse a lower layer of pretend DNA from task A for a new task B. Lower layer example hidden 1, 2, etc. Retain the pretend fixed weights. Upper layer example 3, 4 outputs uh, are trained adapted to the new task. Transfer learning works best when the inputs of both tasks share similar low-level features. Example, age, texture in image. The visual summary of this image is left side is the existing DNA for task A and right side is the new DNN for the task B. Reuses early layer from task A, trains only top layers of the new task. Now here we can learn about pretend model for a transfer learning. When building an image classifier and you lack enough training data, it's a good strategy to reuse the lower layer of a pretend model. For example, exception model. Set include underscore top is equal to false to execute the top layers global average pooling and then say output layer. You can add your own custom output layers suited to your new task. After modifying the model, you can create a new Keras model using the modified architecture. Pretend a model like exception can be adapted to new tasks using a transfer learning, especially useful when you have limited data. Now here we can learn something about CNN variations. Over a time, many CNN means convolutional neural network architectures have been developed. These architectures have driven major progress in deep learning, especially in image recognition tasks. Performance improvements are often measured using error rates in competitions like ILSVRC, ImageNet large-scale visual recognition challenges. Here is the notable CNN models by years. First was the Linet 5 in 1998, AlexNet in 2012, VGG16 in 2014, Inception's V1, Inception V3, ResNet 50, Exception in 2016, Inception V4 in 2016, Inception ResNets, and last one is the ResNet XT, Res, ResNet XT50 2017. CNN architectures have evolved rapidly, improving accuracy and efficiency in visual tasks, with competitions like ImageNet showcasing in the progress. Thank you.